Good afternoon, everyone, especially to Doc Morales. I am Delaida in Piamonte, and the topic assigned to me is about genetically modified organisms. Part of this topic has been initially tackled by Ma'am Minahe last Saturday on genetically engineering processes and techniques. Let's have first this introduction. Genetically modified organisms or GMOs are living organisms whose genetic material has been altered using biotechnology. They have been developed in various fields such as agriculture and medicine to enhance characteristics like pest resistance or produce pharmaceuticals. However, GMOs also face controversy and concerns regarding their potential effects on ecosystems and human health. Regulations and safety assessments are in place to address this concern. Now let's talk about its history and development of GMO. The history of genetically modified organisms dates back to the 1970s when scientists began experimenting with recombinant DNA technology, also known as genetic engineering. This breakthrough allowed for the transfer of genes between different organisms, giving rise to the possibility of creating genetically modified organisms. In addition to that, in 1983, the first transgenic plant was created, producing a tobacco plant resistant to antibiotic kanamycin. This achievement paved the way for further advancement in agricultural biotechnology. Moreover, the first commercialized genetically modified crop was the Flavor Savor tomato, approved for sale in 1994. This tomato was genetically modified to delay its ripening process and improve shelf life. However, it faced challenges and was eventually discontinued from the market. In continuation to its history and development of GMOs, the development of GMOs involved identifying and transferring desired genes into an organism's DNA. The modified organism is then tested and evaluated for safety and efficacy. It undergoes regulatory review and field trials before being approved for commercial use. Now let's move to the importance of GMOs in modern agriculture. First is increased crop yields. GMOs are designed to be more resistant to pests, diseases, and environmental conditions. They can produce higher yields and improve crop quality, helping to meet the growing global food demand. Second is the pest and disease control. GMO crops can be engineered with built-in resistance to specific pests or diseases, reducing the need for chemical pesticides and decreasing the environmental impact of agriculture. Now, the importance of GMOs in modern agriculture. The third one is to enhance nutritional content. GMOs can be developed to have improved nutritional profiles such as higher levels of vitamins and minerals, which can help address nutrient deficiencies in certain regions. The fourth one is drought and salinity tolerance. GMO crops can be engineered to tolerate harsh environmental conditions. The fifth one is reduction in agricultural inputs. GMOs can reduce the need for chemical fertilizers and pesticides, leading to a decrease in the use of potentially harmful substances and minimizing environmental pollution. Now let's talk about the types of GMOs. First one is modified crops and modified animals. Now let's first tackle about the modified crops. Number one is herbicide tolerant crops. These crops are engineered to be resistant to specific herbicides, allowing farmers to control weeds without damaging crops. The second one is insect resistant crops. These crops produce a protein that is toxic to insects, preventing damage to the plant by pests. Another one is this disease-resistant crops. These crops are engineered to be resistant to specific plant diseases such as viruses or fungi, reducing crop loss and increasing yields. Now let's move to these modified animals. There are several types of genetically modified animals, but it's important to note that the use and commercialization of GMAs is relatively limited compared to these GMO crops. These are the common types of modified animals. One is aquavantage salmon, entropy, glowfish, and anti-disease modified animals. Now let's move to the main characteristics of GMOs. These are DNA alteration, novel traits, and reproducibility. Let's first talk about this DNA alteration. GMOs are organisms whose genetic material, specifically their DNA, has been modified through genetic engineering techniques. This alteration can involve inserting, deleting, or modifying specific genes to achieve desired traits. Now let's talk about these novel traits. Introduction of new traits. GMOs are created by introducing novel traits into organisms that do not naturally possess those traits through genetic engineering techniques. These traits can be include improved nutritional content, enhanced resistance to pests, diseases, or herbicides, increased tolerance to environmental conditions, or modified growth patterns. Let's talk about this reproducibility. GMOs are reproducible through genetic engineering. This process involves controlled and standardized modification to an organism's DNA, resulting in consistent offspring with desired traits. This allows for the advancement of various applications, but success rates and stability can vary. Here are some reasons for genetic modification. Improving crop yields. When we talk about improving crop yields, means using genetic modifications to increase the amount of crops produced during harvest, which can ensure food security and meet growing demand. Another one reasons is this nutritional content refers to the essential nutrients and compounds present in food that contribute to our health and well-being. Okay, another one reason is this increasing resistance, means becoming more resilient to external factors or stimuli, fostering improved health and adaptability. In addition to that reasons is this reducing pesticides, means using fewer or finding alternatives to chemical substances used to control pests and diseases in agriculture. This approach promotes sustainable farming practices, minimizes environmental impact, and protects human health. These are the genetic engineering techniques. One is gene editing, transgenic, mutagenesis, breeding, RNI, and others. What is the impact of GMO in the Philippines? Productivity growth of the country's corn industry was estimated to be 11.45% higher due to genetically modified corn adoption, according to the study. How are these GMOs regulated in the Philippines? The Philippines has also ratified the Cartagena Protocol on Biosafety, which requires the regulation of GMOs before they are subject to transboundary movements. So, what is the first GMO in the Philippines? It is said to be the golden rice. GMOs in the Philippines describe the market for genetically modified organisms in the Philippines, including policies that allow or ban them. The Philippines was the first in Asia to approve commercial cultivation of a genetically modified crop. Biosafety in GMOs is a term used to describe efforts to reduce and eliminate the potential risk resulting from biotechnology and its products. So, these are the biosafety issues and concerns, labeling GM and non-GM food, gene transfer, antibiotic resistance genes in GM food, effects on biodiversity, and environmental concerns. Okay, let's move to the potential human health risk caused by GMOs. It's about toxicity, antibiotic resistance, allergic reactions, and immunosuppression. These are the benefits of GMOs. They provide more genetics-related information. They make it possible to make more money. They increase the value of crops. They are noted for lowering food prices. They produce products that have been determined to be safe. To sum up about these genetically modified organisms, have their genetic material altered through genetic engineering to enhance desired traits. Commonly used in agriculture, they can increase crop yields and resistance to pests and improve nutritional content. However, concerns remain about long-term environmental and health effects, leading to debates on leveling and regulations. Ongoing research aims to address these concerns while balancing innovations and safety. To end my topic, I want to read this quote. Innovation knows no bounds, and with genetic engineering, we have the power to unlock new possibilities in agriculture. Through the responsible use of genetically modified organisms, we can create resilient crops, adapt to changing climates, conserve resources, and safeguard our environment. Let us embrace the future of farming and cultivate a world of abundance and harmony.